Alright, so the next video I wanted to make is a how-to on making a startup file for your LS swapped vehicle. More specifically, a Gen 3 24X swapped vehicle. That's going to be your 4.8, your 5.3, your 6 liter with a P01, which is the red-blue, or a P59, which is the red-green ECU. The reason why I want to make this video is because a lot of guys think that you can just go in here and just turn off VATS, and that is technically true. You can go in and turn off VATS, and a lot of times your vehicle will start and run. But there's a lot of things that we can do to optimize this tune to where right off the bat your vehicle's going to run and drive much better, and you're just going to be happier overall, whether you're going to do the final tune or you're going to take it somewhere. We're at least going to have a vehicle that starts and runs. So let's go and dig in. I'm going to be using a 2002 Silverado 5.3 stock file. A lot of times that seems to be the best operating system, but if you've already got a junkyard computer, you could probably just read your file out and use that one. So if you need a quick how-to on how to do that, you're going to open up HPtuners software, and you're going to click this button with the green arrow. And what that's going to do is it's going to allow you to read your stock file. So you're just going to click that, you're going to click this read button. Currently I'm not plugged into a vehicle, so normally when you click that file it would pop up here, the VIN number, type of vehicle it is, things like that. Once it reads out, it's going to ask you to save, and then once you save the file, you're going to end up being right around where we're going to start at now. So for starters, we're going to open up our file, and you're going to come up to here to the top left hand corner and click the open file button. And today, like I said, I'm decided I want to use a 2002 Silverado 5.3 stock file. So we're going to double click that to open. And the first thing it's going to do is it's going to pull up your engine tab. But what I want to do is let's go and start off with the VATS first. So let's just go over here to System. And right here where it says VATS Control, you see where it's set to serial right now. We need to drop it down to none. If you want to just end right there and just get it up and running really quick, all you would do is you would save this file. I would go under here to File and then Save As and then rename it to something else. And then you're going to click this red button to send it in. When you click this red button, you're going to see this drop down tab, and you're going to need to switch it over to Write Entire. That is the best way of sending in a VATS delete file. It has to be done through Write Entire. Anyway, but we're going to do more than VATS. So we're going to close this back out, and let's proceed. So the first thing a lot of people don't understand is the type of fuel pressure regulator that they choose will directly reflect the injector data. The reason being is because most of the truck engines actually have a fuel pressure regulator built onto the rail. So what I'm going to do is let's pull up the injector data first, as injector data is pretty much the first thing that's always key in getting a tune correct. So what we're going to do is we're going to pull up the injector data. So we're going to click Engine, we're going to click Fuel, and we're going to pull up this flow rate versus KPA. Now as you can see right now, it is flatlined at 25.2 pound per hour, and that's what this unit of measure is that I've got mine pulled up to. This green text up here, you can click it and change which unit of measure you're using. I prefer to use pound per hour when it comes to injector size. So right now where it's flatlined 25.2, that means that this vehicle is going to be equipped with a fuel pressure regulator that is vacuum referenced. What that means is as the engine has manifold vacuum, in a normal application you're going to have a one-to-one reference with vacuum, and what that means is when you're in vacuum, it's going to reduce the fuel pressure to keep the injector size stable, keep the delta the same. So if you have a regulator that is built onto your rail that is plugged into a vacuum reference, or if you have an external regulator that you've put a vacuum reference on, you will flatline your injector data like this. If you don't, then what you'll need to do is, if you have a Corvette regulator or it has like a Holley system that has the fuel pressure regulator in the back, you're essentially running what they call a deadhead system, which means that it's regulated back there, you're sending that 58 psi or whatever up front, and in manifold vacuum it's actually going to make your injectors larger. So what you can do in this application is if you have a Corvette regulator, while we're using this 2002 stock file, we can actually get in here and I can search. So I'm going to go to my documents and I can just type in like a vehicle that would be a deadheaded injector size. It'd be 25 or 24.5 pounds. Would be something like a 2005 GMC Sierra. And so I'll just pull up this stock file right here to a 2005 GMC Sierra stock. And so as this opens up, you're going to see that now the things that are different are in green. Now again, if you didn't see how I did that, I clicked compare and open compare file, and I went and selected my file. Now I know from experience that 2004, 2005, 2006 trucks that have the fuel system deadheaded. So if you were running a Corvette regulator on this truck, you can see the difference in injector data. So you'll see right now it's flatline 25.2. This is the way that we can show the file in the background. So if we click that, and you'll see that it's 24.5 at 0, and it's 27.1 at 80 kPa of manifold vacuum. So if you're running a Corvette style fuel filter, then you would want this type of injector data. If you're running a manifold referenced fuel pressure regulator like the 9902 trucks would, we're going to stick with what we have. So anyway, so we've got that. I've discussed that with you. Injector flow rate versus kPa is going to be dependent upon fuel pressure regulator, as well as this offset versus volts versus vacuum. So if you'll notice in our stock 2002 file, you'll see that where all these numbers are flatlined across the board. So we have the same number, this 0.7172 is all the way across. So if we look at our comparison file to the 2005 Sierra, click the compare, and you'll see how it shifts across the board. So the offset will also change whether or not the fuel pressure regulator is referenced. So anyway, so we're going to close that out, and we're going to go start over at general. We're going to look through here. Everything looks good. If you have a 4.8 or 5.3 or 6 liter, you're going to want to change your engine type right here. This directly affects the ECU's VE calculation. So you want to make sure this is correct, and you want to make sure your cylinder volume is correct. And this is liter per 1 cylinder. So say we've got a 6 liter, we can go up here to tools. We go to calculator, and we can just type in 6, like 6.0 liter divided by 8, and then this is what we would enter into that cylinder volume right there. So we want to make sure that is correct. Next thing we're going to do is we're going to go over to, so here's idle. If you run a stock engine, we shouldn't have to mess with anything on idle, not at the moment at least. Under airflow, one thing you'll see is this EGR airflow. Most swap guys aren't going to run EGR. So if you are, you can leave it alone. If you're not, then you can actually go up under here to airflow, and you can just zero out this entire table. This is a calculation that the ECU is using to dictate how much EGR airflow is going to affect your VE or fueling calculations. This filter coefficient right here on a vehicle with no EGR is going to be 0.0039. That is going to be that value. So, all right, so now we can move along. We're going to go to dynamic. Now this one right here is a personal preference of mine. A lot of swap vehicles have induction systems that have changed, obviously, when compared to the factory pickup truck. So what I like to do is on startup is I like to just run them in speed density mode. And what that means is that we're going to use the manifold air pressure sensor to dictate fueling versus using the mass airflow sensor to dictate fueling. So to get over to speed density, what we're going to do is we're going to come over here to high RPM disable. We're going to make this 8,000 just to get it completely out of the way. We're going to come up here to engine diag, and what we have to do is we have to tell the ECU that the MAF has failed. So we're going to just come over here to MAF frequency fail high, and we're going to take it down all the way to 1. And next what we want to do is we want to come over here to DTCs, and we're going to, in order for the MAF to fail completely, it has to set the code. It always has to set it. So you'll see it's P01, P102, P0103. We're going to make this MIL on first error. So you can just click it, or you can use the drop down tab. I haven't made a mistake. So this P0106 right here, we actually want no error reported on this one, and that way if we have an issue with our map sensor, it doesn't completely fail out. Alright, so that's how we get over to speed density. So we're going to go back over to engine, and let's just keep moving on. Now I will say this, if you are running no MAF whatsoever, then your mass airflow sensor value is going to be 0 hertz. So let me show you this. We're going to come over here to general, and this MAF calibration airflow versus frequency, This table is based off of basically the more airflow your engine takes in, the higher the frequency it goes. So the very first value it's going to look at is this 1500 hertz right here, which is going to be the equivalent to 0 hertz. So if you're running no math, we need to actually put in a number that is reasonable for the engine to start up on. With that being said, is because the engine is going to immediately try to start off with math, like mass airflow sensor, and then the second it goes over 1 hertz, it's going to fail itself. So right here we need to just make this say a stock 5.3. This doesn't need to be more than like 7 grams per second, and you'll see this is right here, this grams per second. That's the unit of measure we're working in right now. So we can close that out and keep rolling along. Fuel. All right, so this stoic AFR, a lot of times our pump gas is going to be E10 in the majority of the country, meaning 10% ethanol. Stoic value on that is 14.08. So we're just going to type in 14.08, and what that's going to do is it's going to correct our fueling for our stoic, because otherwise it would be like roughly 4% off. All right, so next thing we're going to do is we're going to come over here to oxygen sensors. Now, a lot of the times these vehicles are open exhaust until they get to the exhaust shop. If your vehicle is open exhaust, you need to get the vehicle where it's stuck in open loop. To do that, you're going to go over here to closed loop enable, and we're going to make this we'll make it 283. And what that means is that we're going to have to go 283 degrees Fahrenheit in order for the vehicle to reach closed loop using the oxygen sensors. So we're going to do that. We're going to close that out. Another thing we're going to do is long-term fuel trims. Long-term fuel trims on a swap vehicle don't usually work the greatest. Usually there could be exhaust leaks, there could be intake manifold leaks, there could be a number of mechanical issues that need to be addressed. So you don't want the CCU learning bad habits until you have it dialed in. So to disable that, we're just going to click disable. Now, just for redundancy, I always make this number match the bottom. So this 131 degrees, I'm going to make it 284. So that's all for that one. Under open loop and base, the only thing we need to change here is because we are going to run this vehicle in open loop, not using oxygen sensors because it's probably got open exhaust. We got to turn this short-term fuel trim open loop off, and that's going to keep the vehicle in open loop 100%. All right, so that's all in this table. Power enriched stuff we don't really need to touch. If you want to, there's a delay in power enrichment. Now, what power enrichment is the additional fuel that you get when you're, say, pulling a hill, you're at wide open throttle or close to wide open throttle. In a stock 2002 Silverado pickup truck, there's a 2-second delay right here. So we can just make this 0. All this other stuff we really don't have to touch at this moment. All right, so next thing we're going to go into temperature control. Now, this is for a vehicle that is not equipped with a catalytic converter. I'm going to assume if you got an LS swap, that vehicle's probably old enough that it doesn't need to go through emissions. So what we need to do is if we leave this on, the vehicle will actually go into cat over temp protection, which will cause it to run rich. So the best thing to do is just disable this right now. Now, again, I'm very OCD when it comes to my tuning, so I like to be redundant. So I'm going to make these 1 right here and 1 right here. And what that was basically telling us is that was the extra enrichment that we were going to get had the vehicle gone into catalyst over temp protection. Let's go over to cutoff deceleration fuel cutoff. We don't need to touch any of this right now. We can go to spark. We don't need to touch any of this other than catalyst heating. If you don't have catalytic converters, we can zero this out. You'll see this table. This is a timing multiplier or a timing adder or subtractor. So you'll see that when you fire up the vehicle, I mean, it's going to adjust, 15 degrees of timing, or down here it's pulling 20 degrees of timing. We don't want that, not on these vehicles. So we're just going to zero this out. All right, so all of these are good. Now, again, I haven't wrote down any of this stuff. This is literally just me going with the flow, just talking to you guys. Retard, we don't need to do anything. Dwell, we don't need to do anything with. Torque management, we don't need to do anything with. Now, this is a big common misconception. A lot of guys think that with torque management, that you just have to max all this stuff out and you have to do this. You don't. Honestly, it's very rare that you'll ever see torque management in this era of ECU limit the vehicle unless it's a big power adder vehicle. But for stock 5.3, adjusting this stuff makes zero difference. I promise you could try it one way or the other. It makes zero difference. Same with right here under spark retard and torque loss. A lot of guys will try to zero this out. This right here is a torque management for your 4L60E, and we all know that 4L60Es need all the help they can get, so just leave this alone. This is going to make your vehicle drive extremely nice. The traction control stuff we don't have to touch. Again, swap vehicle doesn't have that stuff. What we can do is go under, this is under abuse mode. It's torque management and abuse mode. This drivetrain abuse sometimes can get confused on a swap vehicle. So what you can do is right now the rev limiter is set to 6,000 in this vehicle, so we can just set this to 6,000, and this speed we can just make it 0. Alright, so we're done with that one. Engine diagnostics. Alright, airflow, all this stuff is okay. There's no reason to change any of this other stuff. It's all completely fine in factory form, just the way it is right now. Even in speed density, it's completely fine. Don't need to adjust the misfire counter. DTCs. Alright, so this one, I don't want to put this whole list in this video. You can go through, well, what you do is, again, you go to DTCs right here, and you can scroll down. And if you need to disable any of these, you can uncheck this SES enable. A lot of swap harnesses will have an LED for check engine light. This is what dictates whether the check engine light is on or off. So earlier, whenever we did this MIL on first error for speed density, if you have a check engine light, we can uncheck these boxes, and now the check engine light won't be on. Now the vehicle's always going to throw a code for this mass airflow sensor because we're in speed density, but right now it's not a concern. Again, we're just trying to get this vehicle up and running. But you can scroll down through here and see what you want to turn on, what you want to turn off. You'll see that there's a rear, like if you see sensor 2 on the oxygen sensors, that means it's the downstreams, which is the after catalytic converters. We don't need those on a swap vehicle that's not running catalytic converters. So you can turn off any of this stuff. One that a lot of guys miss, including a lot of the companies that do swap harnesses, is it's a P0650. It is actually an MIL for the MIL. And when I mean that, I literally mean malfunction indicator light control circuit. There's a check engine light for the check engine light. So we can just disable this. Again, to disable, it's no error reported. Alright, so that's done. Trans stuff, really big thing. If you say you got a C10 or something like that, most of the time you're not going to run the part neutral safety switch. Good part is the 4L60s in the majority of the applications actually have an internal part neutral safety switch. But even if your vehicle doesn't, what we can do is we can actually do this part neutral safety switch, and we can actually set this to none. And what the cool part is about this is the vehicle still understands park, reverse, neutral, drive. So everything's going to indicate correctly. If you were to actually leave this as PRNDL, it's probably not going to work correctly in your swap. But if you set it to none, it's always going to work correctly in your swap. And you can verify that in your data log. I can show you later on, but you can actually see the PRNDL indicator. And even with this set to none, it still shows up accurately. So we're going to go through shift general. Now this force motor current positive, this is just something for a 4L60. This is a lot of guys miss this, and they can actually burn transmissions up if you try to turn up the pressure and you don't make this adjustment. So we're going to click positive, and you'll see this whole right side. See how above 96 psi is this really high milliamperage of 1245. That's basically going to dump all the line pressure out on the trans. So this 98 right here is perfect, or you can make this 0, whatever. So I always just make them 98, and that's going to fix that issue. Going through shift scheduling is okay. In factory form, a lot of you guys, when you're doing swaps, you don't know your rear axle size or rear axle ratio. That's okay. This vehicle is, we can go to edit gear and tire wizard. This vehicle is set to 30.81 inch tall tires and 373 gears. Regardless as to what your rear axle ratio is and your tire size, the vehicle is still going to shift at the correct RPM that it would have as a stock pickup truck. Now it may not feel correct in how it drives and the shift feel, but it's going to shift through all 4 gears. It's going to lock up. It's going to do everything. Just don't touch it for right now unless you know your gear ratio and tire size. Otherwise, just leave it alone. Shift pressure you really don't have to touch. Again, if we're doing a stock 5.3 with 4L60, 4L60 is actually much stronger than people realize. It's just what usually kills them is guys turning off torque management. We'd left it all alone. Yeah, cruising through here. Everything else is good. All this is good. All right, so we can go under, it's under system options. And this is where brake torque management is. And this is basically to keep the vehicle from wanting to do burnouts. On a swap vehicle, we obviously want to do burnouts. So we're going to click over here to brake. You'll see brake torque management. And you see where this 1 is. 1 means active, 0 means off. So we're going to make this 0. Alright, so that's all good. If you're going to run electric fans, typically what I'll do, actually I'll just go in and show you, is I'll pull up a compare file to a 2006 Silverado with a 5.3. Actually we can just, no, better yet, we'll just use that 05 that we were using earlier. So we again, we're going to come up here to the top, compare, open compare file. I'm just going to go to my documents and I'm going to type in 2005 Sierra. And I'm going to open up that file. Alright, so what you'll see is you'll see where everything in green is what's different. So you can click this button over here, it says show differences, and we basically make everything the same. But the first thing we want to do is come down here and just set fans to 2 fans, and then we can click compare. And then what we can do is we can hit 0, we can type in 0, and this is going to make it to where it matches up with your compare file. So we can just basically go through here and just zero everything out. So you can hit 0, then tab, and then 0, then tab, and 0, then tab, and just keep going until it's all the same. Make this the same. And some of these may not, like this enable temp where you'll see a -0. Obviously there's no such thing as a -0, so we'll just leave that alone. It's 0, it's fine. So right now we'll go back to show main file, and you'll see where all of these are now the same as what the 2005 file was. If you want to make it any, the temp's a little bit cooler, you can just come in here and you can just make this like 196. Like I usually, again, I'm OCD, so if you want to see what I'm doing, I'll click show differences. See where it's -30, so I'll put -30 here, -30 here, and then this is the high side, and I'll make this -30. Again, the way I tune is I try to make everything equal. And I only try to tune for the engine modifications. So went back over to show main file, show where we're at. We can keep moving along. AC. Alright, so if you're going to run electric fans, we need to change this. See this recirculation fitted? We need to make this fan number 2, and that will get both your fans active and working correctly. Speedo we can leave alone. You can go to limiter if you think you're going to go faster than 98 miles an hour. You can raise it. I just leave it alone unless I know somebody's going to need it. Anyway, so that's really it. That's your swap file. So we're going to come over here to File. We're going to save as. We're going to call this 5.3. We'll just call it Startup Swap File. And then save. And then if you want to send it in, if you haven't done the VATS stuff already, you're going to click this red arrow. And we're going to again click this drop down. We're going to go to write entire. You will see where this says brickable, and that is the truth. It is brickable. What that means is you can render the ECU in a state where it no longer works. Best thing to do is going to be just put a jump box on the vehicle, hook up a battery charger to it. We just don't want to drop voltage. Anyway, so after that you'll click this write, and that's it. Obviously you'll see interface not found on mine because I'm not connected to anything, but yours will actually, it'll go to erase and start writing. So yeah, that's the gist of my version of a startup file. That's going to have the corrected injector duty cycle. That's going to have the O2 sensor turned off for open exhaust, which majority of you guys are going to have. That's going to have the MAF disabled. That way we're running speed density. That way there's less chances of the fueling to be off. We haven't touched timing. We haven't touched anything else. This vehicle right here, if you were just using a drive-by cable 5.3 with a 4L60, it would drive beautifully and you wouldn't have to touch it anymore until you wanted to put it into closed loop. And if you were gonna, actually I can just go on and show you, if you have full exhaust and you want to keep it in closed loop, you can go to engine, and you can go to fuel, you can go to oxygen sensors, and what we can do is we're gonna put our compare file back to our stock file, and we can just make this closed loop enable. We'll just have this back to stock, and then go to open loop tab and put this back to stock, and then now we're in closed loop again. Again, that's going to differ on each vehicle, but this is what I do. So I always ask the customer, do you have exhaust on it or not? I ask them if they have a complete factory air intake system or not. Once all those decisions have been made, and then we also ask fuel pressure regulator type. So don't forget, it's flatlined on the flow rate if you have a vacuum referenced regulator, and then otherwise it's going to be a little bit of a slope. So yeah, hope this information reaches you guys well. Again, I wasn't reading any type of script or anything. Y'all got to watch me do it simultaneously. So follow along, subscribe, leave me a comment, give me a like, share. If you've got some swap Facebook pages that you're on, share this video. We've got the C10 clubs and stuff like that. These guys need to know this information, so let's get this stuff out there. Thanks again. Have a good day.